Hello students. In our last video, we have learnt about the energy obtained from sea. Now here, we are going to study the nuclear energy or nuclear power. Have you ever thought about nuclear power? Is it useful or harmful? Let us explore it. It all started way back in 1940s, when the whole world saw the destructive use of nuclear energy on Hiroshima and Nagasaki during the World War. In the aftermath of this disastrous use of nuclear energy, scientists started putting their eyes on various constructive use of this energy, like to generate electricity, running cars and aeroplanes, etc. With a little hard work, scientists concluded that nuclear energy is the future. But it also turned out that nuclear energy was extremely difficult, complicated and expensive. Now, let us see how nuclear energy is generated. Students, nuclear energy is generated from the nucleus of an atom by a process called nuclear reaction. There are two types of nuclear reactions. In one of reactions, the nucleus of heavy atom such as uranium, plutonium or thorium is bombarded with low energy neutrons. This results in splitting of nucleus into lighter nuclei. This process is called nuclear fission. After this reaction, the total mass of products is lesser than the total mass of original reactant. This difference in mass, that is delta M, between the original nucleus and the product nuclei gets converted into huge amount of energy at a rate governed by the famous equation given by Albert Einstein, that is E equal to delta mc square, where c is the speed of light in vacuum. Nuclear fission was first observed in 1939, when a uranium nucleus was bombarded with low energy, slow moving neutrons, and the energy was released. In nuclear fission, the energy is released in the form of the kinetic energy of newly formed nuclei and radiations. During the fission of uranium atom, barium and krypton are formed. This reaction gives out 3 neutrons and radiation in the form of gamma rays. If nuclear fission reaction is allowed to continue, a chain reaction takes place. The gamma radiations released during the first fission reaction excite the protons, which in turn hit the nucleus of the next uranium atom and triggered the next fission. This continuous process generates tremendous amount of energy and radiation. Can you think what could be the use of such fission reaction? Yes, the atomic bomb. The atomic bomb is based on the fission reaction. It uses the principle of uncontrolled chain reaction. In uncontrolled chain reaction, the fission reaction is allowed to proceed without any moderation. This uncontrolled reaction leads to the release of energy in the form of explosion. Now, the question arises, how to control such a useful source of energy? Here is the answer. If we conserve 2 of these 3 neutrons, we can control the fission chain reaction. Cadmium rods are used to conserve the excess neutrons. In this way, the reaction continues in a controlled and more fruitful manner. This controlled fission reaction can be used in nuclear reactors, where the heat produced during this reaction is used for boiling the water to produce steam. Steam so generated is used to drive a turbine for generating electricity. Now, let us see how much amount of energy gets released during such fission chain reaction. Using Einstein's equation, scientists calculate the total amount of energy released in the nuclear fission of uranium. You will study this calculation in your higher classes. To get an idea of the incredible power inside a uranium atom, let's compare it to the coal, which is one of the traditional carbon-based source of energy. Do you know, students, burning 1 kg of coal will produce 8 kilowatt of power, while 1 kg of uranium will produce 24 lakh kilowatt of power. So can you observe how potential nuclear energy produced by fission reaction is? So students, here we have seen that huge amount of energy can be produced using nuclear fission, that is breaking of nucleus into smaller and stable nuclei. The energy so produced can be used to run power plants where electricity can be produced. But can you think of a reaction where two small nuclei are fused to produce energy? Yes, this is possible, and such reactions are called as nuclear fusion reactions. We will study them in detail in our next video.